So now let's take a look here at example number 3. This will be the last example for this section. And it's kind of going to be slightly a strange one because there's not really going to be any function that's going to be given here for us to work with. However, I do think there's going to be enough information to help answer the question. So let's take a look at what we have. Suppose the odometer on our car is broken. Remember, the odometer is just the thing that calculates how many miles you've driven. And if that's busted, right, like it's not updating correctly, but I still want to estimate the distance that I drive over the next 30-minute time interval. Well, there's a way I could potentially do that. I could take the speedometer reading every 5 minutes, let's say, right? So I kind of check in the speedometer. Maybe I have like a notepad with me, or more ideally, I have someone else in the car with me, and I check my speedometer every 5 minutes. That's every 1/12 of an hour, and I say, hey, write this down. This is how fast I'm going. And so maybe I get the following a table of times, right? So like right at the beginning, I look down and I go, oh, I'm going 17 miles an hour. And then after 5 minutes, I look down and I go, oh, I'm going 21 miles per hour. And I do this for a total of 30 minutes, or notice that's 6/12 of an hour, right? It's half of an hour. Now, what if I wanted to estimate how far I traveled, and I wanted to do this using left endpoints? Well, at first glance, this might be like, well, how the heck am I supposed to determine this? This is like impossible. But it's actually very, very simple to see how I could visualize what's going on here. Notice if I have my time as my horizontal axis and my velocity as my vertical, I could imagine these pairs, that is the top and the bottom of this table, as kind of setting up different points. Like I could graph 0, 17 as a first point. I could graph 1/12, comma 21. That would be a little bit bigger. So here's 1/12. I can imagine then where 2/12 is going to be, and 3/12, and 4/12, and 5/12, and all the way up to 6/12. Now I'm not going to be super careful as I plot these points. I mean, I'll just try to roughly eyeball them. 24 is bigger than 21, 29 is bigger than 24, 32 is bigger than the 29, this one's going to be a little bit lower, and this one's back a little bit lower again. Now I have no idea what sort of curve connects these points. It could be that these are all connected by a nice kind of semi-straight line. That's possible, but maybe not. Maybe my speed is doing this all the way in between, right? Like I have no idea. Maybe my curve looks like that. I can't connect the dots with this picture right now because I don't actually know how this drive actually went. I don't know when I was speeding up and when I was slowing down. But with this information alone, I think we can sketch everything that we need. Notice if I wanted to use left endpoints, I could still start by stating here, okay, I kind of have 1, 2, 3, 4, 5, 6 rectangles that I could draw. And if I'm interested in doing left endpoints, I'll just start at the left side, go up until I hit my function, which I know would occur at that dot, and then I can go ahead and I can draw out my rectangle. And so I can still generate all of these rectangles even if I don't actually have a function that goes with them. So notice here, I'm sketching out all of these. A rough picture. Now I don't even necessarily have to draw that out, but this at least can show me now it's going to be really, really easy to go ahead and say that my total distance that's going to be traveled can be estimated by just saying, well, first, how wide is each interval? That's a 1/12. And then let's go ahead and just find the heights of each one of these rectangles. The first rectangle has height 17. The next one is height 21, then 24, and then 29. Notice I'm just kind of moving down the line here. But keep in mind I only have 6 rectangles, right? So I'm going to see that now I've already written down 4 heights, that's 5 heights, and this is 6 heights. Notice that the value of 28 here is not included. And of course that makes perfect sense because 28 would have been this point right here, and that's not the height of any one of my rectangles. So if I was to add all this up and simplify out, I think I end up with a 1/12. This inside is 140 or 154. You could double check me on that. And I think that ends up then as 77 over a sixth, or 77 over 6 miles, which is roughly in the range of 12.83 miles. We would estimate that's roughly about how far that we traveled. Now it's also hard to tell from this if that's an overestimate or an underestimate. We don't really know because we don't have a picture of the function. So we don't know the picture of the exact area. Well, notice that nothing much here would change if my distance traveled was instead going to be using my right endpoints, because I'm still going to have rectangles that have a width of a 12th. But now I'm going to imagine creating rectangles that instead would have gone up and actually touched the right end and gone over. And so I would have had a different starting rectangle because instead of using the left point to determine the height, I would have used the right point. So notice that instead of using 17 for the height of the first rectangle, I would have used 21. Notice, for the height of the second rectangle, I would have used the right edge, which would have been the value with 2/12. That's 24. And then I would have continued all the way down the line. Notice that this time I would have gone all the way over to the value of 28, because here my blue rectangle would have looked like gone up to the right point and then over and then down. So I can kind of see how my rectangles here would be changing. If it's helpful, you could draw a totally separate picture of just all the blue rectangles. You would see that we get these values, and of course I could simplify this down. This is 1/12 times 165, which is actually exactly 13.75 miles. So I can see here I can get two approximations. I don't know which one is more accurate, and I also don't know if either of these are overestimates or underestimates. But very surprisingly, with even just this very limited information, I can provide these estimates. I don't even need the full function. And that's kind of a really cool idea and allows us to make approximations for a whole bunch of things if I just kind of have some individual data points moving along the way. Now, it's important again to practice the idea here of Riemann sums, and you should go to the 5.1 worksheet to try to help with that. On that worksheet, there's a whole bunch of different questions that you can try to work through to test your understanding on questions like these where no function is involved, and questions where you're going to have areas above and below the x-axis, as well as using left endpoints, right endpoints, and midpoints.